Have you ever stopped and wondered if a machine could actually learn the way we do? I mean, not just crunch numbers, but really truly learn? Well, that single idea is the spark that launched an absolute technological revolution. So today, let's pull back the curtain and demystify the incredible world of deep learning. It all boils down to this one powerful question. It's this quest to see if we can build something artificial that mimics our own ability to learn. But, to even begin to build an artificial mind, you first have to understand the original, the real deal. And that blueprint is, of course, the human brain. I mean, think about it. It's the most complex, most efficient learning machine we know of. It's the ultimate inspiration for all the technology we're going to be talking about. Inside your head right now, there are billions, with a B, of these tiny little cells called neurons, and they are constantly chattering away, sending signals back and forth to each other. It's this massive, interconnected web that lets you understand what I'm saying, remember what you had for lunch, or come up with a brilliant idea. It is all about the power of the network. So the big question is, how on earth do you copy that? Well, take a look at this. On one side, you've got our biological neuron. It takes in stuff, sights, sounds, chews on it for a second, and then fires off a message. On the other side, we've got its digital twin, the artificial neuron, which we usually just call a node. It's basically a little bit of math, a computational unit that does the exact same fundamental job. Takes in data, does a quick calculation, and passes a result along. Okay, so one of these artificial neurons is kind of neat on its own, I guess. But the real magic, the thing that changes everything, is when you start connecting a whole bunch of them together. That's when we start to build something that looks a lot like an artificial mind. And that leads us to the artificial neural network, or ANN for short. It's pretty much exactly what it sounds like, right? It's a network of all those artificial neurons, those little nodes, all linked up and talking to each other. It's our best shot at recreating the brain's incredible structure inside a computer. Here's a really great way to picture this. Imagine a huge, sprawling system of pipes, like a giant plumbing network. Now imagine water flowing through it. That water, that's your data. And the pipes, those are the neurons. By opening and closing different valves, you can control where the water goes, guiding it to a specific destination. That is almost exactly what an ANN is doing with information. So what does one of these networks actually look like? You might be picturing something super complicated, but the basic structure is surprisingly simple. In fact, you can think of it like a sandwich, a 3-layer sandwich. First, you've got the input layer. That's your bottom slice of bread. This is where you feed in all the raw data. Then, in the middle, you've got the hidden layers. This is the good stuff, the filling. This is where all the heavy lifting, the real thinking actually happens. And finally, you have the output layer. That's your top slice of bread. It spits out the final answer. Simple as that. Okay, so we've got the structure, we've built our sandwich. But here's the million-dollar question. How does it actually learn anything? This is where it gets really, really cool. Let's use a little story to see this whole thing in action. I want you to picture a group of kids, and let's say none of them has ever seen a panda before. We're going to show them a bunch of pictures and get them to figure out what it is. Now here's the catch. Each kid, just like a single neuron, can only focus on one tiny detail. But if they work together as a team, they can solve the whole puzzle. And check this out. This process lines up perfectly with our sandwich analogy. Step 1 is observation. This is our input layer. One kid notices black and white fur, another one sees big round ears, a third sees a certain face shape. Then comes sharing insights. That's our hidden layer. They all start talking to each other, combining their little clues. Hey, my round ears totally go with your black and white fur. And finally, they reach the verdict. That's the output layer. They take a vote, and together they all shout, "It's a panda!" But what happens if they get it wrong? What if they guess it's a cat? Well, we just tell them, nope, that's not right, try again. And this feedback is the learning part. Think of it like a scoring system. Each kid's opinion carries a certain amount of weight. When the group gets the answer right, the connections between the kids who led to that right answer get stronger. Their opinions get a little more weight next time. And when they get it wrong, those connections get weaker. It's this constant process of tweaking and adjusting those weights, based on feedback, over and over again, that makes the network learn. After seeing thousands of pictures, it tunes itself to become an expert panda spotter. So, we've got our artificial neural network. It's learning, it's getting smarter. But you've all heard the term deep learning. So what's the deep part all about? Where does that come in? Honestly, the answer is going to sound way simpler than you think. Deep doesn't mean it's more profound or anything like that. It literally just means we're adding more of that yummy filling to our sandwich. A deep neural network is just an ANN that has multiple hidden layers stacked on top of each other. That depth, that's what allows it to recognize way more complex and subtle patterns in the data. And this deeper structure is really what separates deep learning from what you might call traditional machine learning. Older models are simpler. They often need a human to go in and tell them, hey, these are the important features to look at. But with deep learning, you don't have to do that. The network figures out the important features all by itself, as long as you feed it a truly massive amount of data to learn from. So let's wrap this up. What are the key things to remember? First, deep learning is just a powerful, specific kind of machine learning. Its whole structure is inspired by our own brains. It uses those deep, multi-layered networks to learn from enormous datasets, which is why it's so incredibly good at tackling really complex problems that not long ago seemed impossible for computers. And this isn't some sci-fi, far-off future stuff. This is happening right now. Every single time you talk to Siri or Alexa, use a translation app on your phone, or see a self-driving car on the news, you are looking at a deep learning system in action. It's already woven into the fabric of our daily lives, solving problems in ways we could only have dreamed of just a decade ago. Which, leaves us with one final really big thought. These incredibly powerful networks, at the end of the day, they're just reflections of the data we feed them. They learn what we teach them. So the real question for our future isn't just about what these machines can do, it's about what we as humans will choose to teach them next.